Okay, get where you can see well. Put all those phones away. Pay attention. I'm going to show you something. Last thing I'm going to show you, and this is all we really have to do in Module 7, and then we're done with Unit 3 completely.
Are we going to work out all today?
Yeah, I think you'll get to. Yeah, you'll definitely get to. We can be quick. I think we can do quite a bit of work if we hustle through this. So here's what I want you to see. So let's read this question together carefully, because half of the test and half of the 7.2 assignment is just like this. So what it's really asking us to do is almost work backwards from reverse the thinking we've been doing in the past. Thanks, sir. Okay, so they're saying write a polynomial function of least degree that has integer coefficients, the given zeros, and a leading coefficient of 1. Okay, what in the world does that mean? So the stuff that we normally do, we normally start with some big polynomial, and we factor it, and then find the zeros by setting the factors equal to 0, right? Agreed? So for example, maybe we'd end up doing some polynomial. Let's just say hypothetically we had some polynomial, and after we did all the hard work of factoring it, let's say we ended up with something like x minus 1 times x plus 2 times x plus 3. So that's, and we want to find out when that equals 0. That's what our polynomial factored into after we factored it, right? Okay, what would the zeros be that would go with those factors?
X plus 1, x minus 2.
Okay, so, but you don't mean x plus 1, you mean x equals 1, right?
Yeah.
Okay, so this one would be if I set that equal to 0, right? If I set x minus 1 equal to 0 and solve, I would get x equals 1, right? Okay, and there's one of my answers. If I set this guy equal to 0, I'd subtract 2 from both sides and get x equals minus 2, my second answer, right? And then finally, I'd set this guy equal to 0, and you remember why? Because we're using the zero product property. The product of factors can only equal 0 when you multiply by 0, right? So we get x plus 3 equals 0, so x equals negative 3, right? We good?
Yes.
Okay?
There's no 3.
Say it again.
There's a 2, 5, and negative 2.
No, I know. I'm doing a different problem. I'm saying this is what we normally do down here, right? Now, what if we wanted to reverse that? What if instead we were given, we said, okay, here are some zeros. X equals 1, x equals negative 2. Yeah, good. We're just going to work backwards, right? If I gave you these zeros and said, build the polynomial that they come from, that's a lot easier than what you've been doing, right? Because factoring is relatively hard to do. This is easy. All I would have to do is say, okay, the 0, x equals 1, goes with what factor? We already know the trick for that. We just subtract the 0 from 1, don't we? And that would recreate what is set equal to 0, right? That's the factor. It's the factor that we set equal to 0, right? So all we're really doing is subtracting the 1 from the x, and that's going to give us that factor, right? Subtract negative 2 from x minus negative 2 is x plus 2, right? Subtract negative 3 from x, and we get x plus 3, right? Yeah. Everybody getting this?
Yeah.
Okay, so then the last step would just be to take those 3 factors and multiply them together, and that's it, right? So you try that. I'm going to see if you can build the polynomial that has the factors 2, 5, and negative 2, okay? Try that. All right, so first steps first here. Justin, what's the first thing I'm going to do?
You're going to say, based on parentheses, go x minus 2.
Okay, so this one is going to give us the factor, so I know that f of x is going to equal an x minus 2. Now what? An x minus 5. And what else? An x plus 2. Okay. This is just an accident that we happen to get a 2 and a negative 2, but there's a reason I put those together. Okay, because sometimes when you're multiplying these out, sometimes it's easier to multiply in one way than another. Right? Hey, Valerie, why don't you get rid of this real quick? I want you to hear this. So the reason I'm going to multiply these two together is because they look like conjugates, right? This is a pattern that's easy to multiply, and it's a good thing to recognize when you see it. what's the answer to this? If I do the conjugate pattern, a plus b times a minus b, if those are conjugates, because they're the same terms, but one time they're added and one time they're subtracted. That's all it takes to be conjugates. If they fit that pattern, a plus b and a minus b. Well, if you multiply conjugates, what do you always get? A squared minus b squared. Yeah. Every time, right? You don't have to go through the whole process. It's always going to be a squared minus b squared. So then why would this make sense? Well, because doesn't that look like, that looks like a minus b times a plus b, where a is x and b is 2, right? You see that? So then, Gage, what am I going to get for that answer if I multiply those out? X squared minus 4. Very good, right? And then all I have to do is multiply that through by x minus 5, and I'd be done. And that's not a big deal, right? All I'd have to do there, let me get rid of this stuff. I hate to get rid of that stuff because I want it in my notes. All I'd have to do, you guys are probably okay with this. This class, you guys are doing so, I mean, you're far and away ahead of the other Algebra 2 classes. I feel like probably you're in great shape on this. Let's at least talk through what we would do. I would just distribute the x squared through to both terms, right? So if I did that, what's that going to give me? If I distribute the x squared, I'm going to get, whoops. Yeah, I'm going to get x cubed and then minus 5x squared. Now what if I distribute the negative 4 through? And then plus 1. Okay, and so all I'd have to do then is potentially I'd have to just add up like terms and put it in the right order, but in this case it worked out so it just happened to end up being perfect, right? I don't have to switch anything around, there are no like terms, but there could have been, right? Okay, that was quite a sneeze. Okay, so there's my answer. Now what about something like this though? Let's try one that's a little bit different. I don't know. Don't know. I haven't planned that far. Okay, what about this one? What about this one? This looks a little different, maybe a little scarier. I've got a square root in there. Okay, so what are going to be the zeros? I mean, the factors that go with these zeros. Okay, so I'm going to have an x minus 3. No, it's just going to be x minus the square root of 3. Because that 0 is the square root of 3. Okay, but here's what I want you to see. If the instructions are saying, everybody take a second and just, I know it's Friday afternoon, but this is, you got to put on your thinking caps for a second here and really focus on this or you're not going to get it. Okay, so if we're doing what the instructions tell us to do, it says write a polynomial function of least degrees. We want it to be the smallest, easiest polynomial we can find. It has to have integer coefficients and a leading coefficient of 1 and these zeros. Okay, that's going to be, as it's written right now, that's impossible. Because if I expand this out, would you agree that for sure I'm going to end up getting some square roots in my result? Right? Okay, so impossible. I would have to add another 0 here that's somehow going to get rid of the square roots. Okay, and that does happen. There's a rule called the irrational, I'll just write it down. It's called the irrational root theorem. And what it says is this. It says that if a polynomial has rational coefficients, what's that mean? Rational coefficients. What's a rational number?
1.
1 is an example of a rational number. A rational number is any number that can be written as a what? As a, what's ratio mean? Fraction. Any number that can be written as a fraction. Okay. So it wouldn't include things like square roots, for example, because they can't be written as fractions. It has to be written as a fraction where I have integers on the top and bottom, right? So if I want to have a nice polynomial that has rational coefficients, which this one would have to do, right? If we wanted to have integer coefficients, then integers are rational numbers. They just have a 1 on the bottom, right? If I want that to happen, then if there's a 0 in the form a plus b times the square root of c, if x is equal to something like that, right, where a, b, and c are just numbers, then there also has to be, that goes with that, there has to be a partner. They have to come as a pair. You have to have the conjugate of that 0. So instead of the plus sign, we're going to put a minus sign in, right? So let's look at our situation up here. We have a square root of 3, right? So this square root of 3, what are the values of a, b, and c for this 0? It has a square root in it, right? So it has to match this. Let's see, the square root of 3 by itself. What's the coefficient? Because b is just the coefficient of the radical. Well, what's the coefficient there? It's 1. Yeah, we don't write it, but it's a 1, isn't it? So we could put a 1 out in front. What's the number that's being added to the term with the radical? Well, no, the 3 is separate. This is it. It's just the square root of 3 is the other 0. So what must be out in front if it doesn't even show up? 0. Yeah, it'd be 0. Would you agree that 0 plus 1 times the square root of 3 is exactly the same thing as the square root of 3? Right? Now, we don't have to write it that way. That's fine. But when we want to find out what the other partner, conjugate partner is for this factor, we have to think of it at least for a moment in this form, right? So if one of them is a plus b times the square root of c, the other one has got to be a minus b times the square root of c. Well, we already said that a is 0, b is 1, and c is 3, right? So what's the conjugate going to look like? It's going to look like 0 minus 1 times the square root of 3. Well, how would I write that one more simply? What's 0 minus 1 times the square root of 3? Yeah, just negative square root of 3, isn't it? Right, so the one that would go with this, so here's the square root of 3 gave us that factor. 3 gave us that factor. Well, we'd also have to have another one out here. We'd have to have a minus square root of 3. That's the partner with this one, right? What factor is that going to give us? Plus. It's going to give us x plus the square root of 3. That solves the problem, because watch what happens here. When I multiply these together, this is just like saying a minus. This is like saying a minus b times a plus b if a is x and b is the square root of 3, right? Okay, so then that's that conjugate pattern, a minus b times a plus b. Make sure. Not here. Oops. Sorry. So what's that going to give us then? If we multiply a minus b times a plus b, what's the result?
A squared minus b squared.
A squared minus b squared. So what does that look like for us? X squared minus b squared. What's b squared going to be? What's the square root of 3 squared?
3.
3, right? Because think what that does. If I take the square root of 3 squared, doesn't the square root and the square just cancel?
Yep.
Right? So we get x minus 3. And then all we have to do is multiply that out front by another x minus 3. How about that? Right? And if we do that, what do we get? So if let's distribute the x. I'm going to get x cubed minus 3x. Let's distribute the minus 3. minus 3x squared plus 9. So there are no like terms, but I could at least put it in the right order, right? Put it in standard form. So I got to put the x cubed term first, then I'll put the minus 3x squared, and then the minus 3x, and then the plus 9. And that's our answer, right? Okay, make sense? Good? Okay, grab Chromebook and log in real quick. I want you to try number 2. I'll show you which one to try. And this is on your homework, so you're getting your homework out of the way here.
Thank you.